Hello everyone, and now I am going to show you how to do the exercise number 3 for the course GIS tools for climate change studies. And as you can see from the screen that I have already made the whole or the entire workflow in the model builder, but I'm going to show you in most of the steps how this is run and what possible errors you could find if you didn't do it the correct way. But before we go there, I want to show you some of the requirement that you have to do. So you go here in the map, and I have the files here. If I check the catalog, then I have here the files that I need for the exercise. So before you start, make sure that you have these files. The first one is the DEM that is uh, required, which you could easily import it from exercise number 2. And yeah, if you don't have it in the folder, you can just right click here and connect it to your folder and then find where the file is, where the folder is. But from this folder, the one that we want in this exercise is the DEM, that's the DEM that is clipped with the watershed that's assigned for your case. And for this example, I have it here in my folder, and then I went here, and then I just right click here and copy, and then go back and yeah, paste it in my folder here. That's what I did here. You can see it here, and then I brought it back here in the map. And the other files that you need are there is also watershed assigned for each of you. And then this you will find it from the exercise 3, and that is for this case, for the example, this is the folder, but inside you can see that these two raster files, one for the buildings and the other one for the water bodies is included, and those are the two one you can see them here. Yeah, so these are the one that you need as a requirement before you start your your workflow. And of course, you need also the watershed boundary if you can find it as well. It's just, this is also the watershed that's assigned for with your name and ID. Once you have this, and then yeah, so as you can see, this is what it look like. And yeah, also make sure so that the coordinate system is correct. For example, if it is something different, just right click on the map and go to properties and go to coordinate system, and then make sure that you have this ETRS 1989 UTM zone 32, because this is what we use for this area, and it's in Trondheim, so it's 32. But sometimes you might find it the 33 one. If it's 33, so probably we'll see it a little bit tilted, so make sure that it's straight and looks good or fit with the screen. Yeah, so if you don't have this, if it is something else, you just need to go in the search and write ETRS 1989 and then UTM zone 32. Then you can find it. If you enter, then you will find it here, and or you can go to the if you are familiar with this, you can just directly go to the projected and then UTM and then go to Europe, and then ETRS 1989 is somewhere here. Yeah, ETRS 1989 UTM zone 32, this one, and then you can also click this and it will come back. If you click this, it will be in there in your list of favorite um, uh, yeah, projections. The next time you don't have to go back here and search for it, so you can just easily find it here. Yeah, so this is very important to remember. And then yeah, so you have already your folder, and yeah, so I would like to spend more time on the model done on the model builder done on this, because this is already you did it in the previous exercise. Yeah, so I have the exercise number 3 text in my screen, and I will go uh, more or less in most of the steps and see what you can do. Yeah, so the first step is the first step says is the fill tool that we will run, which as you can see here, yeah, so the whole model is here already fixed, but you can we will go one by one or more or less in most of the steps, so don't worry about how this become like this. And so there are in the exercise or in the text, it's been asked for you to uh, use the fill tool twice. The first one is this, as you can see, and then the next one. So here, the numbers you can see, the number you see here, 2. Maybe if I have another third one, it will be 3, 4, and continue like that. It's just based on how many times I am having the tool here. So here, what you will do is, it has been asked in the text that for the first fill, make sure that you have the Z limit of 0.05 meter, which means it only fills for the things that are less than 0.05 meter deep. So that's what you see here. And then the second one is without any, meaning that what does this fill tool perform is, if you put a number, then it fills, if you put number in the Z limit, then it fills all the things that are below that number. As you can see, when I point it out here, you can see that the Z limit is 0.05, so it only fills the things that are less than this one, less than 0.05. But in the second one, if you leave empty the Z limit without any number, then it fills, it means it's the default, it fills all the things, whether it's above 0.05 or 1 meter or whatever. So these are the two questions that are asked. And as you can see, some of you maybe have already had this error that if you don't put any number in the Z, it will be nothing. It will show you nothing in the it will be white color. So let's see, for example, if when you want to edit the number, you just right click in the box, and then here I open it. Then if I remove this, let's say I don't put anything here, then if I say okay, yeah, so you can see that this doesn't have any color, so it means that something is wrong, or at least I have to fix it. Because so what does this field is going to do is the same as what this field is going to. So there is no difference between field number 2 and field number 1 here. So we don't need to repeat the same thing twice, which means we have to make here something different. That's why it's been suggested that 0.05 meter is being taken as a number here. So always make sure that you have the number here, right click on it and see the Z value here, 0.05. Then say okay, now the color will be changed. Yeah, so this is common in most of the workflow. If you have the box without any color, which is white color or empty, then it means either it's not linked well or something is wrong. Then you have to check it and make sure that you have you have a color. Yeah, so as I said, the second one is just you put as it is without any, you don't put any number in the Z limit, so just leave it like that empty. Yeah, then it says given number, file name as an output. That says, for example, if I go here, it says given number name ASF, which is all things field. because it's the default one, and then here is given name, file name that is SSF for the small things field. Yeah, okay. Yeah, so we have this output, and then the next step is the minus tool. Yeah, so the next step is the minus tool, and then if I double click on it or right click and open is the same. So it asks us to put the this minus tool is mainly in this step is doing to subtract the raster or the cells, the value of each cell between the all things field and small things field. So make sure that you have put in the input raster number one as the one that says all things field, and the second one is the small things field. So you're going to, this tool is going to compute the difference between these two, because yeah, so that's what it's going to do here. And then so make sure you have it in this order. The first one is always the all sync field. It doesn't matter what name you have here. If you have it as ASF, then it's okay. If you have another name, but make sure it's the one that have all the things field. And then this one is the second one, which is the one that we set with 0.05 meter in the previous field. Yeah, then say okay. And then of course you have the name the same as what is shown here. And yeah, so I'll move on to the next step, which is yeah, so the next one is the con or the conditional. This tool is simply a tool that has this conditional statement. If it is true, then it gives, if it is true, then it takes the value that we put in the true value. If not, then it will give, if it is false, then it will give no data to the other cells. So for this case, we have been told to put 1 in the true value, and then the rest will be no data. So, and in the expression, we will write if the value is greater than 0, then it will be this true value. This is exactly the same as what is written in the text. So I think this is very straightforward, and I guess you will not have any problem with this one. And then you just make sure that you put 0 here, and it's this one is greater than 0. And so what does this tool is, it gives 1 to the all the cells that have values greater than 0, but to the others it will put no data. Then say okay, and yeah, the next tool is the reclassify tool, and here as you can see we have two different reclassify tools. And I will go one by one. I will open first the first reclassify tool, and then here it's been mentioned in the exercise that to reclassify this um, the blue spot that we have, and then with two different new class. So what you see here is the existing value, and what you put here is the new value that is going to be as a new output. So it's been said that for the one, just give two classes. If, for example, if you go here classify, and then you can choose two class and then say okay, and then because here it says 9, but if I put 2 and then say okay, then I get two different classes here. But this, as you can see, is wrong because I have two the same class. Then if I just delete this, then it's 1 and then the no data should be given 0. Then I can edit like this and then put 0. Then it should be fine now. Yeah, so but at the beginning you always go here and choose two class, and then these are the new two class that will come up. Yeah, so always make sure for the 1 you give 1, and then for the no data you give it 0. And yeah, so the output raster, it says give file name that says plus spot pre number 3, then that's what is here, and then say okay. And it says repeat the same step for uh, for for the number for the second reclassify, which is if I click here and open it again, then similar thing. As you can see that they have two new classes. These are the old one, the existing one, or this one, but these are the new one that I want to classify them with two different class. One for the values that have one, and for the no data, then 0. So, but this is for the buildings, which is so these are buildings are the files that you saw at the beginning. So this one you can link up. Of course, if at the beginning, yeah, let me repeat this one more. If I right click here and open here, as you can see, I can go in and then choose the building that I have, because this is the when it's at the beginning, then it will appear at the top. These are the files that I have in the map. But here it says model variables. These are the variables that are in the model. So I have to choose the first one, which is this one. Then when I say that, okay, and then it will link up with then it will bring it up here, the R buildings, and then link up with this one. And then I have the output here. So this is one, and then the next, after doing these two, we classify. The next one is to use the minus tool, so that subtracts the the blue spots and the buildings. If I open this, so it says this is exactly the same as what is mentioned in the as input. It asks to choose the blue spot pre number 3, or you can make this number 2. Basically, it's number 2 in the text. Yeah, so I call it number 3, but you can make it still number 2. So yeah, so the naming is not a problem. You can have any different name, but always remember that they are linked up with the correct workflow. And yeah, the second raster is the buildings that we have as an output from reclassify number 2. So what it does basically is the two output we have from reclassify 1 and 2. Then you're going to subtract this and then get a new new blue spot that doesn't have any buildings. Says blue spot with no building, because we're going to subtract the buildings from the blue spot here. Then say okay. In the next step, we will do the reclassify number 3 and 4. So number 3 is still continuous from the already we had the minus tool that subtracts the blue spot and the building, and then this is the file that has no building. Then we use that in the reclassify number 2, and we want also to reclassify this for into, it says in the text, classify it into 3 different classes, 3 different new classes. So these are the one that are the new, and these are the existing one. So as you can see from here, it rearranges based from the minus and then 0 and 1. Maybe this is a little bit different in your PC, but it doesn't matter as long as you put for -1, put no data in your new class. For 0, no data. For 1, 1, which means this keeps the same, but the rest is going to be no data. Yeah, and then you give it file name and output file name, and then but make sure also you choose this value, not count or something else in the reclass field, and say okay. This is reclass number 3, and then the reclass number 4. If you right click here and open it, so this is again the new reclassification for the water bodies that we want to, or it's asked in the question that we want to exclude or remove the rivers and coastal or these lakes and whatever this water bodies, and then reclassify them with 1 and 0. So the no data that are outside, then we'll get 0 new class, and then the one with 1 will still be the same as 1. Then you say okay. So reclass number 4, as you can see, is it takes our water bodies. This is the raster water body file that is in the current map. That this is the only one that links up with this one, because there is no any link before. And then there is an output here that says our water bodies number 2, and then we have the blue spot with no building from the reclassify that we made new one. And then the next one is the minus tool again. Then subtract this will subtract the no building file we have with the one that we get output from the water bodies. Then make sure that you have it in this order, and then okay. Okay, good. Next step is the reclassify number 5, and I'm going to open this, and this is the last reclassify we have in this workflow. And then it's asked to reclassify the old values with what you see here. So it's been asked to reclassify the value that says 0 with no data, and then the value that says 1 with keep the same one, and then this actually comes by itself because by default there is this no data that comes up, but the only one that I made classification are these two. So these are the one that are, it just pops up by itself, so don't worry if it appears there. Even if I delete it, it comes up again. So but the main thing that you need to make sure is that the 0 value, that is, this is the old one, that is existing 1 0, should be reclassified as no data in the new one, and the 1 will be the same as 1. Then when you have this, and then you give the file name the same as what is mentioned in the exercise, then say okay. And then the next one is the region group that's after the reclassify. And then if I right click here and open it, and here as you can see, yeah, so it takes the output from the reclassify number 5, and then you give file name as an output for the raster file, and then you take 8, you choose the 8 because it goes to the 8 neighbors or neighboring cells, and then yeah, so you put same as what is shown in the text as well. This is already shown in the PDF, so this is very straightforward. You only need to choose the correct files and give the file name and say okay. And after this, also the next step is the add field. This add field tool will add new field to the table, to the attribute table. So here it's been asked to add a new field that says volume because we are going to calculate volume in the next step. So this will add volume, and then make sure that the field type is float, and then with single precision, and then yeah, everything is straightforward here as well, and then say okay. And then I will come back with the most important, or at least some of you I have seen, because I'm also linking up this discussion with the discussion forum we have in the course, that some of the questions that have been raised there, I'm trying to answer them here. So that's where, so I have seen some questions from the zonal statistics, so I will go a little bit more with this one, and then we'll continue with the next step. Okay, so now we will continue with the zonal statistics as table. As you can see, there are two zonal statistics as table we will use in this step, and then two join field as well. So the most important thing here is when you work with any one of these zonal statistics table, remember that you have the correct file name. So for example, here for the first zonal statistics, the input is, for both of them, the input is always the blue spot regions we have at this step. This is the blue spot region we have after we created the BS blue spot region first, and then we add a field that has field name called volume. And then this is what we have here, because we are going to calculate the volume. And then we have this blue spot region. This is common for both zonal statistics. So as I said, it doesn't matter with which one we are having as the input raster, but it always important to have the blue spot regions, the second with number 2 for both of them as input raster or feature zone data will be the blue spot, because for each of these blue spot regions or zone is where we would like to have the input value raster. So the input raster, if for example for the first one, for my case I choose the SSF, the DEM SSF, meaning the DEM with the small things field, and then remember to have the output table name as unfilled one, because these are the small things field, so they are not totally filled. That's why in the text it's mentioned that maybe better to call it some unfilled tables. This is an output table that will be created straight away after you run this tool. It will create a new file geodatabase table, just only table. You will see later when I will add it in the arc here, but this will be created as an output when this tool is run. So make sure that you have this, the name that says sum and field depths for the one with the small things field or SSF, and then the same thing will be for the zonal 6 number 2, but this will be changed with the other DEM that we have, which have all the things filled, and then the name will be filled. We will check out that. And then another important thing is also, as it's mentioned in the text as well, that make sure that you have the the statistics, because we want only to select the one that are sum. You can of course select all as well, but it's not important to have all. If you choose all, it means it includes the mean, maximum, minimum, range, standard deviation, sum, everything here. But that's not what is required here. We just choose only the sum, and then this will give you the sum of all the unfilled tables that are here, which means the elevation. It it shows the sum elevation values for the unfilled or for the small sink field. Yeah, then say okay, and then next go for the second one, and then open it, and then do the same. So the input raster or feature zone data will be the same, this region, but in this case for the input value raster will be the all things field, and then the file name is field, some field tables, and here is also the same, sum is chosen. You have to choose the sum and then say okay. Then we are done with the two zonal statistic field. So the next one is the join field. So we have two join field here, one that joins the output that we have for the unfilled, for the sum of unfilled divs, and together with the blue spot regions, and then the other one will be that continue with this one. So the thing here, what I said is, so it doesn't matter which one we join first, because anyway there will be a link. For example, instead of joining the unfilled first, if you join the field one with the blue spot region here, and then the second join field will continue from where you stop here and then with this one. But for this case, for example, with mine, I have the first join field. If I open it, then this joins the blue spot region I have here, which is still common for the zonal statistics as well. And then make sure you choose, of course, the value field, and then I choose the unfilled, the sum unfilled depths, which I have here as an output. And then also here the output join field should be value, but make sure here that you have the sum as the join field, because you want to join this sum you have from the unfilled depths together with the sum you have from the filled one where it joins here. So what does this, the second join will do is it joins the sum that is available from the unfilled one, which we'll find it here, and then joins it together with this sum of the field, and then brings one blue spot region that has both the sum unfilled and the sum filled in this region. So the first step here is to only join the blue spot region you have here with only the unfilled, some unfilled depths. So make sure that in the first join field you choose. So as I said, it doesn't matter if you choose the unfilled first or the filled one. But if I choose this first, then this will come up here, and then this will continue in the second one. But for example, if you go with the same as what you see here, then make sure that you choose the sum unfilled as the join table. So it's going to join this table from the unfilled with the blue spot region. Then you choose this the field only the sum. Then say okay, this is what it does here. And then next in the second join field, I will go here and open it. And then this will do, okay, there is one output from the zonal statistic number 2, which has the field, all things field table, and it joins with the one that has blue spot region with the unfilled depths. So here you can see I chose this blue spot region number 3, which is here, which is a combination of the unfilled and then the blue spot we have here. And then of course the input join field will be valued the same. Then the join table, now the table will be another table, which is the one that has field, then still sum. So as you can see, there is sum here, and there is also another sum in the previous join field as well. But these two sums, when they come up here, or when we do the calculate field, they will not be the same sum field. One of them will be sum underscore 1, and the other will be sum without any underscore. So that one we'll find out here which one is which. And yeah, so you put this here and then you choose something and then say okay. So until here we are here now, we have the blue spot region that have attribute table for both the filled and unfilled depths. Then we come to the calculate field, which does the calculation for the volume that we want. And then if I double click here or right click and open, this is what you see in the calculate field. So here I will go a little bit slow here. As you can see, you choose the latest blue spot region, and then the field, make sure you choose the volume, because what we want to calculate is volume here. And then here, make sure you choose the expression type as Python, because this is the only one we have here. We're not going to use any SQL or Arcade, so we will only use Python for this case. And then you have to write the expression here. So as you can see, this is what it looks like. Maybe in the text, it's not the same as this in the text file, but you can make your own expression. It's very easy. You don't need to make it complicated. It's very, very easy. So uh, in the text, if you see, it says the volume is simply calculated as 1 times 1 times the difference between the two sums. So either you can just do the difference between the two sums, or you can simply yeah, either you can write it the same as what is been write. You can write 1. If you want to use the time is also here, the symbols, for example, times is here, I can use this one and then write 1 again here, then I write 1 and then times, then it says the difference between the two sums. So it's, I have to open the bracket, and then, so as I said before, we don't know which one is sum underscore 1 or sum. So if you just click, if you double click on one of them, let's start with the first one here. If I double click, then as you can see, this is the sum, and then here, and then it should be minus, and then the other one. So because I select this, then I select this one again. As you can see, the second one is the underscore sum. So this is the way you can see which one is. So one of them is, this one is from the field and the other one is from the unfilled. So, but this is not the correct equation, so we have to rearrange it in the way that it should be the sum underscore minus the sum. So for this one, you can just edit, go like here, and then minus the first one. and then I will close the bracket. Then it's done. This is the expression that you. So as you can see in the probably in the text there is a curly bracket and then yeah, some other. But anyways, if you write like this, then it's fine. Or you can copy this or write it by yourself. It's not a problem. Then once you have this everything, and then just say okay. Then this will finish the calculate field we have here. Okay. So in the next step, or the next step is the flow direction. And then in this flow direction, it's mentioned also in the text that the input should be the DEM that have all the things field, meaning DEM ASF. If you name it like this, it will be the DEM ASF or the one that has all things field. And then the output flow direction raster, the file name that you want as an output. You could suggest to give it as flow direction ASF and then of the output drop raster as R drop ASF. Then yeah, this is straightforward or the same as in the text. Just say okay, that's finish. And then the next one is the watershed, and that one is here, as you can see. And yeah, so here in the watershed tool, if I just zoom it in a bit, that as you can see the input for the watershed is the flow direction is that we have the output we have from the flow direction from the previous tool, and then the other input that we need or as pour point is the blue spot regions we have from the after the calculated field we have here, or the latest blue spot you will have in your workflow. And then make sure you choose the value in the pour point, and then the watershed is FF will be the output name that you will get from here. And then say okay. And then the next step is also straightforward. It says build raster attribute, because what you have an output here doesn't have any attribute, so we want to build a raster attribute table. And then this is simply very straightforward. You just need only one input raster, which is the watershed SF if you have output from the watershed tool. Then say okay. Then the next one is to add field that we want, because we want to calculate the area for this we want to calculate for the area for each polygon that we have in the watershed. And then you have to add field and then make field name that will be in the attribute table will be watershed area. And then make sure you have the float as the type, field type, and then say okay. And then finally calculate the field. And then here, this one is also similar to what we had previously, but in this case it's the area, so it will calculate the area of each polygon, or in this case, yeah, each polygon that we have. Yeah, so as you can see, it's calculate the area is 1 times 1 times 1, 1 times 1 times the count field, because this count is here. So always do the same as what I showed you before. When you are here, yeah, double click the count or open parenthesis. Since we have only one field, then it will not be problem. When I say double click here, then it's fine. Then that's how it comes up here. And then yeah, so this means that it calculates the area, because this is the count field. If you see in the attribute table, it shows the number of cells you have in one yeah, how many cells you have. So because since um, the file, the elevation we have is 1 meter by 1 meter, so it means that every cell is 1 meter by 1 meter. So if you want to calculate the area, it will be 1 times 1 and then times the count, how many cells. If you have 5 cells, then all of them, they have the same width and the depth. So it will be that's why it's like there is no any factor here. It will be the same as what you have. Or if you have 5 number of cells, then it will be 5 square meter. Yeah, So then we say okay, and then yeah, so we are now done with the first run, which means we are ready now to run the model. This is the first step because in the whole workflow you are supposed to run it twice, which means the first part you run, and then after you finish this, and then you continue with the next one. So this is, if you are in the text file, you will find it. This is the first run that says run model after calculate field. Yeah. So, but before we run the whole workflow, the first part, it was one thing that I want to tell you as well. So that I forgot to mention here is you have to go before you run. You have to go to the environment and make sure that you set the extent and the snap raster to the same as your watershed. Because if you see in the if you see here in the environment. Yeah, when you see this environment, because this is I already set it up for my case, but for your case it will not be like this. So this will not appear. It will be something empty or nothing will show up here. And then yeah, this one as well, there will be nothing. Yeah, there will be nothing here, but you have to choose the extent, and then yeah. So it will be nice also to choose the output coordinate system that will be the same as your DEM or your, and if you choose one of these, then it will automatically bring the the coordinate system that you have, or you can also say current map is also the same. So yeah, this is the output, the coordinate system that will be given to the output file you have. And the other one is the extent. This extent is very important so that it doesn't go processing outside your watershed. So you should choose always the same as the watershed that you have. So here, if I say the same my watershed, then it will be this one will be selected. So as you can see from here, when I choose the watershed, then this will be the number will be displayed. These are the boundaries for the watershed. Then finally, not finally, but the snap raster will be nicer. So if you choose the snap raster, the same as the my DM2 or the DM that you have, and then and also the cell size is also important. If it's processing raster, it will have the same as the DM. This is for the raster analysis. If there is raster analysis in the workflow. Yeah, once you finish all this, then say okay, everything will be set, and then you are ready to run the first part of the workflow. So if I go to the model builder and then auto, if I click here the auto layout, it brought up this and then fit to window. This is what you see. So here you see that there are extra ones. These are for the next step that I had them here with me, so we don't need them for now. I'm just running only the first part, which is what you see here, the color one. As you can see here, this is not colored. That you can see it's white color, so which means nothing is going to happen here. Yeah. Okay, so now it finished run the model finished running, and then I'm going to check what the output will look like in the first part. So, but before that, as you can see from this screen, this is the model display output, and then here you can see that I'm going to see if there is any error or warning or something information here. So as you can see from here, it says succeeded. So if there is this text that says succeeded, then it means there is nothing, no error or no warning. So you shouldn't have any warning or errors if you follow the same step as what I showed you in this tutorial. So as you can see here, all the steps are done without any error or warning. This is just the output. Some of these texts are showing the file's name, the folder name, and then things like that. So there is nothing wrong or error here. Yeah, so when this is run, then you can close it and then come back to the catalog. If you don't see the catalog, if you are here, then click on the view and then catalog pane, and then this will display. So here I want to see and add files that are output from this first part. So the two files that are most important here you should remember is one is the watershed SFF file that we have the last output, and then the other one is the blue spot regions. So what are these? So if you remember this watershed, in the watershed output we calculated the area. You see here the watershed area. If I open this, you can see that this watershed area. So if I add this file in the ArcMap, so I should, in the arc view here, I should see this field in the attribute table and also the area for each polygons. And then the other thing that I want to see is the BS region, the blue spot region. This is the one that we calculated the volume by subtracting the sum number underscore 1 from the sum. So this is also another important one, but this is not the final blue spot region, but at least for the first part, I would like to see if the model run correctly or not. So here you go to your working directory or folder. That's where I have here. This is the folder that I saved, but as you can see from here, there is nothing displayed here. It's only 3 files which are the same as what we have here. So what we need to do is, if this thing happen in any work, in your next work or any work that you will have, so you always have to right click here and refresh. If you right click in the folder and refresh, it will display the files that were output from this model. So if I do a refresh, then as you can see, there are a lot of other files that were hidden or not displayed here. So from here, the one that I want is the watershed underscore SFFF. Then I need to find this file, which is the last one. Then I want to add it and bring it here to see it, to make it visible. So I will add it at the up somewhere here. This is one. And then another one is what I want. The other one that I want is the blue spot region. So this number 7 is not displayed because this is just the 7s in the model, but not in the file name. So the file name should be BS regions. There will be only one BS region, so I will add that one as well. Then bring it back here. Yeah. If you see from here, the low and the high numbers here are the same as the watershed. Because if you see at this stage, it's already part of the watershed in the workflow. That's why you have the same kind of number 168.839, 168.839. This is for my case. So for your case, it will be a different number, but it will not be different number. I mean, this number will not be exactly the same, but both the BS region, blue spot region, and the watershed SAF will be the same kind of high and low values, but the attribute table will be different, of course. So this is one, and then yeah, so here I don't see any map because I'm in the model view. If I click here in the map view, then I can see my map. So this is the map that I have, and this is what it looks like. Yeah. Yes. So now here, so this thing you see is from the DM. So if I uncheck, if I remove the other all files, only keep these two. These are the output that we have. As you can see, it's within the watershed boundary. There is no any extra or outside here, which is good because that's what we did with the extent and the snap raster in the environment, if you remember. Yeah, so then I will right click and open the attribute table for the watershed here. And yeah, so you can see here the attribute table, as you can see, is for each of for every polygon there is an area. This is the watershed area that we calculated, if you remember, from using the calculate field. So as you can see here, it has an output which is really good. So it means that we have succeeded the watershed area calculations or the output. And then the other one that I want is the blue spot region, and open the attribute table. So here you can see that there is an output, that there is volume, that we calculated, and then the sum 2 that we joined together. As you can see here, you can see that there are different numbers here. So these numbers will not be the same as in your case, but you should have some numbers here. Some of them are negative, and then you will get also positive somewhere here, and then yeah, that's the value. So totally there are 168 above 100, more than 168,000 uh, yeah, sales or values here. So if you get something like this, and then it's reasonable or it's a good, you are in the right track. But if you only get an output that has only one row, like just this only one, then it means something is wrong with your work. Then you have to follow the same as what I showed you in the previous steps, how you do it. So then if this is here, then it means it's fine, and then you are ready to go to the second part. So I will just close it here, and this one as well, and I also remove it from here, and then I will also remove from here. Then I will just stick with the two files that I had, and then these two as well. And then I will go back to the model, and then I will continue with the second part, which is now from here until to the next second part. So in the second part, you don't need to rerun the first part, or you don't need to run the whole. You already run until here, you have the output. You just need to continue from here and then run the next steps, which are not that much, but of course it will take also some time. So this part took almost around 15 minutes, and then the next one will be a little bit more from my work, but we will see how it goes. Okay, then in the next video, I will show you how you will start with the second part. And as you can see, these are the second part that I had from this workflow. So I'm going to, of course, I don't need to drag this back and for so the here I can do it automatically, but these are the tools that you need. So the first one you need is the join field, and then you need the add field and calculate field, and then you need the raster to polygon field, and then you need the dissolve one, and then you need another join field, and then you need add field and make feature layer, and then finally the calculate field. So this you will find them directly from the text, from the PDF text file. And yeah, so we'll continue with the second part in just in a very few minutes.